વિદ્યાર્થી મિત્રો, લક્ષ સ્કૂલ ઓફ સાયન્સ બામણમાં ઓનમાં ફરી એકવાર આપણું સ્વાગત છે. આજે આપણે થોડીક સ્કૂલની યાદ કરીશું. ઘણા દિવસ થઈ ગયા સ્કૂલ જોઈને. આપણો ઓનલાઈન અભ્યાસ ચાલી રહ્યો છે. થોડીક સ્કૂલની માટીની સુગંધને અહીં આપણે જોઈશું તો મજા આવી જાય. તો ચાલો સ્કૂલની ઝલક જોઈએ. આપણું સ્કૂલનું આ સિમ્બોલ, આપણી આ સ્કૂલનું બાહ્ય દેખાવ કેટલો સુંદર છે. જો ભારત માતા સાથે આ આપણું એન્ટરન્સ. અહીંથી તમે અંદર સ્કૂલમાં વારંવાર જાઓ છો અને યાદ આવતી હશે બધી. કેટલું સુંદર અહીં લાગી રહ્યું છે. આ આપણે હોલમાં બેસીને પ્રાર્થના કરીએ છીએ, ભેગા થયા છે, મિટિંગો યાદ આવે છે કશું? હાલના શબ્દો નિલેશભાઈ ને આપણા વાતો બધી તો બધું મિસ કરી રહ્યા છે. તો થોડુંક આજે આપણે એને દિલથી યાદ કરી લઈએ એવી ઈચ્છા થઈ. જાત જાતની એક્ટિવિટીઓ આપણે કરીએ છીએ. આ બધું ખૂબ જ યાદ આવતું હશે. પ્રવાસો હવે તો આ વર્ષે ભૂલી જવાનું છે. આ બધું રમતો સ્કૂલને આ રીતે આપણે યાદ કરીએ અને પછી ભણીએ તો મજા આવશે. Welcome back, dear students, to the Lux School of Science, and we are discussing in chemistry lesson number 9, the coordinate compounds. Dear students, in previous video we have seen about the how the compounds are formed, and in that case we have said that how the ionic compounds are formed, how the covalent compounds are formed, and how the complex compounds are formed. Actually, in chemistry, complex compounds are very important because they are produced by some another method. We have seen in that case the electron pair is donated out, and that electron pair will give the extra electron from itself, and that's why this is known as coordination covalent bond. Now, here such kind of compounds are known as complex compound. Dear students, in modern chemistry, these complex compounds are actually known as these are known as actually coordination compound. So that's why the lesson heading is coordination compound. Dear students, these coordination compounds are everywhere in our life, not a few things. It is related with our life, and these are very important. For example, in our body, whatever the hemoglobin is there, hemoglobin is the coordinate compound. We see in plant the green color, it is due to the chlorophyll. Chlorophyll is also a coordinate compound. Next thing, if we talk about, then lots of medicines we make, that also nothing but the coordination compound. Dear students, if we talk about today the cancer disease, and this cancer disease is also cured by cisplatin, this is also one coordinate compound. Also, if we go with our body, then dear students, today one regular complaint is there that we tired early. આપણે જલ્દી થાકી જઈએ છીએ. So in that case the doctor suggests us that there is a lack of vitamin 12, and this vitamin 12 is also, dear students, coordination compound. So coordination compounds and its world is very important for us, and that's why we can say that chemistry is the heart of the industries, because in each and every industries the color, the dyes as also majority dyes today we are using are nothing but the coordinate compounds. So these coordination compounds are very important, and that we have to study very nicely. The coordination compound firstly observed or the separated or the its a phenomenon was given by the Swiss scientist Alfred Werner. Actually, in his experiment, he has derived lots of interesting things, and that interesting thing today we are going to talk about. But before to study that, I would like to give you some important replacement of this kind of compound or important thing to understand about the coordinate compound. So today's our target is to study coordinate compound. So dear students, when we talk coordinate compound, we have to separate out this compound from another compound. Actually the complex compound we can say. The simple compound is what? Simple sentence you know na? Simple sentence ની અંદર શું હોય? એક સેન્ટેન્સ હોય જેની અંદર ઓબ્જેક્ટ હોય, સબ્જેક્ટ હોય, વર્બ હોય, ઓકે, પ્રપોઝિશન હોય ને આવી નાની નાની વસ્તુ બનીને એક સબ્જેક્ટ બને, એક સેન્ટેન્સ બની જાય. બટ કોમ્પ્લેક્સ સેન્ટેન્સીસ આર ધેર જેની અંદર બે સેન્ટેન્સ જોડાઈ જાય અને કોમ્પ્લેક્સ સેન્ટેન્સીસ બને. So such kind of complex compounds are there. The simple compounds, ચલો simple compounds AgBr છે જેમાં સિલ્વર અને બ્રોમિન જોડાઈ ગયા છે. Very simple, nothing is there to speak about. FeCl3 છે જેમાં એક Fe અને 3 Cl જોડાઈ ગયા છે. This is also simple compound. So these are the simple compound. But when we talk about the complex compound, then we used to write these things. K2 Al2, અહીંયા બે પોઝિટિવ આયન તો થઈ ગયા, અહીંયા સિંગલ સિંગલ જ છે, અહીંયા બે પોઝિટિવ આયન થઈ ગયા. K2 Al2 SO4 tetrais 12H2O. This is nothing but the potash alum. This is nothing but the potash alum. And in our regular use to speak alum stone, in Gujarati we used to speak as a fatakdi. Okay. તો અહીંયા આપણા પાસે એક compound છે જે K પણ છે, Al2 પણ છે, SO4 tetrais પણ છે અને water પણ છે. તો અહીં આપણા પાસે આ compound complex થઈ ગયું છે because it has two positive ion and negative ion. So it is complex. So here question arise in our mind, whatever it is possible, क्या वो बनी सके? Actually we have also another compound KMnO4, K2Cr2O7. Here see, these are also such compound કે જેની અંદર more than one positive ions are there. Okay, so here we have complex compound in which we are having more positive ion and a single negative ion or more negative ion also. Okay, so such kind of compounds are known as complex. These are the simple compound. Here we are going to discuss how this potash alum is produced. Actually here we have K2Al2SO4 tetrais 12H2. So when potassium sulfate, that is K2SO4, react with combined with aluminium sulfate, that is Al2SO4 thrice, and it is producing K2Al2SO4 3 and SO4 1, that is SO4, and water molecule is absorbed by this and potash alum is produced. Okay, so this is very simply we have produced potash aluminum. Here you can see 2 2 2, so this empirical formula can be also made KAlSO4 twice. So empirical formula can be also made from this. Okay, so potash alum is formed. So this is our first part to understand. Now second part we are talking about is very interesting also. Suppose we have FeCl3, ferric chloride, and suppose this ferric chloride is reacted with 4 times KCl. અહીંયા FeCl2 લઈ લઈએ, is reacted with 4 times KCl. Ferrous chloride is reacting with 4 times KCl. And dear students, the production is this K4FeCl6. So just look like this. Both are there. અહીંયા આપણા પાસે શું બન્યું હતું? So here we have made potassium aluminium sulfate, which is known as potash alum. Here we have produced is nothing but the potassium ferrous hexachloride. Okay, so this is our production. So I hope that you understand both the process of making. Okay, now first of all side, we understand that these both are same, but actually both are not same. These are different. So in which manner they differentiate each other? So come on, let's dissolve this in water. પોટાશિયમ ને વોટરમાં નાખીએ તો પોટાશિયમ ને વોટરમાં નાખીએ તો એનું કમ્પોઝિશન શું થઈ જાય છે જરાક જોજો. 2K પ્લસ છૂટું પડી જાય છે, 2 એલ્યુમિનિયમ પ્લસ 3 છૂટું પડી જાય છે અને 4 ટાઈમ SO4 માઇનસ 2 છૂટું પડી જાય છે. So this is its compositions કે બધા આ રીતે પાણીમાં નાખતા છૂટા પડી જાય છે. Now we are adding this thing in water. So what is happening here? 4K plus is separated out and FeCl6 minus 4 is separated out. You understand this? Very simple. जो एकदम simple છે understanding करवा. When we are talking about this, potassium sulfate is reacted with aluminium sulfate and some amount of water is absorbed out. At that time, K2Al2SO4 twice is produced and 12 water amount is absorbed out, and this is known as alum stone, fatakadi. Now FeCl2 is reacted with 4KCl. At that time, it is producing K4FeCl6. 4K times Fe1 time and 2 plus 4, 6 times Cl. But when we are dissolving them in water, at that time here K plus aluminium plus 3 SO4 minus 2 such ion is separated out. And when we added this thing in water, then 4K plus FeCl6 minus 4 is produced out. Gappa. Yo, sir gappa. કેમ ક્યાંથી ખબર પડી ગઈ કે આ K plus aluminium sulfate બધું છૂટું છે ને ક્યાંથી ખબર પડી ગઈ કે આમાં આ છૂટું છે ને આ છૂટું નથી? પાણીમાં જ નાખેલું છે ને ક્યાંથી ખબર પડે? So I have answer. When you are studying the practical of chemistry last year, at that time you have done such a practical કે તમને એક કમ્પાઉન્ડ આપી દેવામાં આવતું હતું ને કમ્પાઉન્ડના તમે અંદર કંઈક નાખો તો તેના પ્રેસિપિટેટ મળે એટલે આપણે એમ કહેતા હતા કે ભાઈ આ છે. This thing is we are talking here. So now dear students, when in potassium aluminium sulfate solution, that is in solution of potash alum, when we add picric acid, આપણે અંદર શું નાખીએ છીએ? Picric acid નાખીએ છીએ. At that time yellow precipitate is observed, and this yellow precipitate is sign for the presence of potassium. એટલે potassium અંદર છે. Now second thing, now we are adding NH4OH, aluminium hydroxide, and due to the addition of aluminium hydroxide, we got aluminium hydroxide na white precipitate. When we are adding, આપણે જ્યારે નાખીએ છીએ એમાં ammonium hydroxide, ત્યારે આપણને white precipitate મળે છે. કોના? aluminium hydroxide ના ચીકણા white precipitate મળી જાય. When we are adding there AgNO3, silver nitrate, which is for the negative test. Okay, negative ion ને શોધવા માટેની ટેસ્ટ છે AgNO3 રાખો. So when we are adding AgNO3 there, at that time we will get slightly blackish precipitate of sulfate and silver sulfate. That shows us that here potassium is present separately, here aluminium is present separately, here sulfate is present separately. So this is the confirmation that when they are added in water, they get separated out in this manner. So this is our first point to understand. Now we are going to talk about second point. And second point is interesting about this. Now we are adding again picric acid. Then again we are getting yellow precipitate, and that confirm the presence of potassium in this case. Potassium hexachloroferrate. પોટેશિયમ હેક્સાક્લોરોફેરેટ ની અંદર આપણે જ્યારે શું નાખીએ છે, picric acid નાખીએ છે. At that time it is giving us the yellow precipitate, and this is confirming that yes, there is a potassium. Okay, now we are adding to get the FeOH thrice. White precipitate એના આવશે, slightly dull white precipitate. તો એ કરવા માટે આપણે એની અંદર એમોનિયમ હાઇડ્રોક્સાઇડ નાખીએ છીએ. No precipitate. It means Fe is not separated. You got the idea? Precipitate બનતા નથી. That means Fe is not present there in its own form. Now we are adding AgNO3 to get white precipitate of chlorine. And dear students, here also we are not getting white precipitate of chlorine by adding AgNO3. That means chlorine is also separated. And that makes us sure that here Fe and Cl6 are not in separate form. Okay, so you understand, this is the different thing. So in this case they all remain separate form. In this case they are not remaining in separate form. That is the basic talk. Here we are talking about the complex compound, and due to that the complex compounds can be separated into another part. એક જે પોતાની ઇન્ડિવિડ્યુઅલ આઇડેન્ટિટીને ઇન્ટેક રાખે છે અને જે પોતાની ઇન્ડિવિડ્યુઅલ આઇડેન્ટિટીને લોસ કરી દે છે. તો આવા બે પાર્ટમાં આપણે વેચી શકીએ. તો ડિયર સ્ટુડન્ટ્સ, in which the individual identity is intact out, this kind of complex compounds are known as dual salt. તે લોકોને શું કહેવામાં આવશે? ડ્યુઅલ સોલ્ટ. એકચ્યુઅલી આ બંને સોલ્ટ છે, જુદા જુદા છે, પણ જ્યારે એલમ બને છે ત્યારે એ જુદા જુદા ખાલી ભેગા થઈ જાય છે, પણ પોતાની સેપરેટ ઇન્ડિવિડ્યુઅલ આઇડેન્ટિટી એ લોકો લોસ કરતા નથી. ધેટ ઇઝ ધ એવિડન્સ કે બધા સેપરેટલી છૂટા પડી જાય છે. But in this case, these are known as the coordinate compound. And this coordinate compound, when these two individual salts are combined with each other and they give the new kinds of compound which are known as coordination compound, they will not sustain their individual identity. They lost their individual identity. Only here potassium is getting its individual identity. Other two are losing their identities. And that's why such compounds are different from the above. These are known as dual salt. એક સાથે બે salts રહ્યા છે અને they intact છે. Here they lost and they become positive and negative ions separately, and these are known as coordinate compounds. Okay, so here we can differentiate the two compounds. One is known as dual salt, while another one is known as coordinate compound. So today in this section we are going to talk about only coordinate compound. Now we will not discuss in this lesson the dual salt. We are going to talk about only coordination compound. Now here we can discuss that how these coordinate compounds are behave, why they are forming, why they are different, and what is the understanding of this, and that we are going to discuss just now. Okay, so chalo, we are taking the example of first, when cobalt chloride react with ammonia. When cobalt chloride react with ammonia, then it forms a new compound which is nothing but the CO NH3 6 and Cl3. This is the first compound. Here 6 ammonia is worked out. If instead of exhaust ammonia, suppose we have take some less amount of ammonia, then this will give us cobalt ammonia 5 Cl and outside Cl2. Such thing if we produce going on કે હજુ એક લેકિંગ ઓફ એમોનિયા કરી દઈએ અને instead of 5 ammonia, suppose we are taking 4 ammonia, then this is producing a new compound having 4 ammonia, 2 Cl inside and 1 Cl outside. So the reactions of cobalt chloride, this experiment is not actually I have done. This experiment was done by Alfred Werner, the Swiss scientist whom I was talking earlier. That Alfred Werner's experiment has done this thing. Okay? Here, when we are talking about cobalt chloride react with ammonia, if excess of ammonia is done, then this some less than the different. ગપ્પા સર અલા આ બે રિએક્ટ કર્યા તો આ જ મળ્યું એવું તમે કેમનું કહી શકો? I have answer. My answer is that when particularly this compound is observed, so its color is different, and આ color different હોય એટલે આપણને ખબર પડી જાય its color is yellow. આ yellow color નું છે. When this is formed, ammonia ઓછું લેવાઈ ગયું તો કલર બદલાઈ ગયો, and this color is violet color, and this color is green color. Now tell me, it is proof? Is it proof? Yes, it is proof. Okay, when we are talking about the color, then the excess of ammonia is taken, then yellow colored this compound is formed. When some less ammonia is taken, the violet color this compound is formed. Is more less ammonia is taken, by green color this compound is formed, and that is the evidence. But you will not accept this. કે કલર ડિફરન્સ આવે એનો મતલબ એવો થોડો છે કે કમ્પાઉન્ડ છે. યસ, કલર ડિફરન્સ આવે એટલે કમ્પાઉન્ડ ડિફરન્ટ છે, બટ કેમિસ્ટ્રી needs more and more work કે ભાઈ આવું ના ચાલે. So what is the another evidence? So another evidence is this. See, when this thing is there, I would like to write this COCl3 into 6 ammonia. આ છે ને COCl3 અને 6 ammonia છે એની અંદર. Okay, now this is reacted with AgNO3. કેમ રિએક્ટ કર્યો હશે AgNO3? અને તું ગેટ ધ સિમ્પલ કે આ આની અંદર રહેલા જે નેગેટિવ આયન્સ છે એ નેગેટિવ આયન્સ સેપરેટલી ઇન્ડિવિડ્યુઅલ આઇડેન્ટિટી ધરાવે છે કે નહીં એ જોવા માટે આ કર્યું. તો ઇન્ટરેસ્ટિંગલી here 3 mole of AgCl3 was produced. કેટલા મોલ? 3 mole of AgCl3 was produced. When same thing is done with this, okay, when same thing is done with this, COCl3 5NH3 when reacted with AgNO3, it has produced 2 mole of AgCl3. Oh sorry, AgCl જ આવશે, AgCl3 નહીં આવે, AgCl 2 moles of AgCl. Interesting. Now in this third case, when COCl3 4NH3 was reacted with AgNO3, then it has produced 1 mole of AgCl. Now can you tell me કે yellow color જે હતો આમાં આ yellow color છે, આ violet color છે, આ green color છે, then these has produced different amount of HCl. પહેલા કેસમાં કેટલા મોલ મળ્યા? 3 મોલ. બીજા કેસમાં 2 મોલ. ત્રીજા કેસમાં 1 મોલ. Now can you tell me why here we are getting 3, why 2, why 1? Can you tell me? See, observe carefully the everything. I am zooming this for you. Observe करो बराबर. चलो observe करो शांतिથી અને tell me. Check out this department check करो અને પછી આ check करो. You will get the answer. Check it. Yes, you correct. Here how many Cl is outside? 3 Cl is outside. Means here 3 Cl are not inside this box and they are separate. And as they are separate, it has produced 3 mole. એ લોકો include થયા નથી. Here 1 Cl is gone inside. It is included in the square area. And that's why we are getting 2 mole of HCl. Here 2 Cl gone inside, only remaining 1, and that's why we are getting 1 mole. And this is the evidence of this formula. And this is the evidence of that formula. That means our supposition or the ours not Werner suppositions that okay, here cobalt is behaving in different manner. And what is different manner here? Is here see COCl3, here COCl3, 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 COCl3 બધામાં બરાબર જ. બટ એ આઉટસાઇડર સાથે અહીંયા +3 આયન થી જોઈન થયો છે. અગર આપણે એને સેપરેટ કરીશું તો this is CONH3 6 +3 +3Cl minus. In this case, if we will differentiate this, then this will be behave like this: CONH3 5Cl +2 +2Cl minus. And same thing here, you can write here plus and here Cl minus. So it suggests that okay, we have got separate ion. અહીંયા +3 નો ion, +2 નો ion, +6 નો ion. But see, check out inside. +3 valency કોબાલ્ટની, કોબાલ્ટની +2 valency, કોબાલ્ટની +1 valency. આ valency તો છે જ. But check inside. Here ammonia 6 times. Here ammonia 5 and 1 Cl. Total become again 6. Check out this. 5 plus 1 6. 6 only. 5 plus 1 6. 4 plus 2 6. So inside 6 number remain intact. That means outside here +3 +2 +1. But inside 6. So it has maybe 2 valency. One valency by with it reacting with chlorine, and by another valency with it reacting with the ammonia and chlorine both. અહીંયા ખાલી ammonia સાથે reaction કરે છે, આમાં ammonia chlorine સાથે. So we can say that some compounds, those are the coordination compound. Coordination compound has 2 kind of valency. One valency is known as primary valency and another valency is known as secondary valency, and that is the law of Werner. So Werner suggests that some compounds are there, some elements are there, these are having 2 valencies. One primary valency, with it combines with the combined with the negative ions. And secondary valency, with it can combine with the neutral ion or negative ion. And that is the talking point of the next day. With this, here I am ending the video, and we will meet tomorrow with the new interesting thing. Up to this, bye bye.